Okay, so today we'll be learning about linear equations. We're going to look at linear equations written in slope-intercept form. We'll also learn how to graph linear equations written in slope-intercept form. And some of the standards that we're going to cover are the 8th grade standard for equations and expressions, graph proportional relationships, interpreting the unit rate as the slope of the graph. We're also going to use similar triangles to explain why the slope is the same between any two distinct points on a non-vertical line in a coordinate plane. Okay, and we're also going to solve linear equations in one variable. Okay, so let's get started. So first we're going to graph y equals 2x. And what we're going to need to do is we're going to have to solve for a few points, find a few solutions to this equation. So I found 5 solutions, and what I did was I fixed the values for x. So as you can see, I just picked random values for x and I plugged it into y equals 2x and I solved for y. Then I took these values and plugged it back into this column right here. So now I have 5 data points so that I can create a graph. So as you can see here, I plotted my 5 points and then I connected a line that goes through all these points. So I want you to notice how I labeled my graph. I labeled my x-axis, my y-axis. My tick marks, I labeled every 5 instead of every 1 because if I label every 1, it's going to look very crowded. And on my line, I have arrows on both ends of my line to say that my line goes on forever. Okay, all the points on this line are solutions to y equals 2x. It's just that I only plotted 5 solutions, but every point on this line is a solution. Okay, so what I want you to do is I want you to take a moment and find the slope to this equation, or sorry, to this line. Okay, how would you do that? Okay, so I want you to see here this, oops, that's a little too, okay, so slope is just the unit rate or rate of change, and the unit rate is how does the y grow for every x that grows. So if we see here, we have many of these triangles. Okay, so this triangle up here, the y grows for every 1 that we move to the right. Okay, and in this triangle, when x grows 2 units, y grows 4 units, which is also the same thing as if we find out the unit rates, it's the same thing as y grows 2 for every 1 that x grows. And same thing for here, okay? X grows 3, but y grows 6, so that's the same thing as 2. And I want you to keep in mind what the slope is for this graph and how that relates to our equation. Okay, now we're going to take a look at another equation. So we're going to try to find the graph for y equals 3x minus 1. So what we're going to need to do is find a few solutions to this equation, and I found 5. Okay, and same thing, I fixed values for x, so I just picked a few numbers for x, plugged it into the equation, solved for y, and then plugged it back into this column. So here I have 5 data points, and then I plotted these points onto my graph, and this is what it looks like. Okay, so if we want to figure out what the slope is, okay, we can just take any 2 points. So again, the slope is we want to know how y changes for every x that changes. Okay, So this one tells us that this triangle right here tells us that y grows by 6 for every 2 that x grows by. Okay, and this slope triangle here tells us that y grows 3 for every 1 that x grows. Okay, and I want you to take a look at these two slopes. How does it relate to this equation right here? So we know that 6 divided by 2 is the same thing as 3. Okay, so how do these two slopes relate to our equation? Okay, now let's take a look at one more equation. We have y equals 3x plus 1. So I did the same thing. I found 5 solutions. So this is what I did. Same thing. I just picked a few values for x, plugged it in, solved for y, and then plugged it back into this column. And then I graphed my points, and this is what I got. Okay, so let's figure out the slope for this line. So for every 1 that x grows, how much does y grow? So it looks like y grows 3 for every 1. Okay, so let's take a look at all 3 lines together. So if you remember the slope for this first graph was 2. The slope for this graph was 3. And the slope for this graph was also 3. Okay. So if you see here, the coefficient in front of x gives us the slope. Okay. So now we're going to take a look at how an equation written in slope-intercept form can tell us what the intercept is. So we're going to graph this equation right here, y equals 2 over 3x plus 1. So we're going to follow the same process. We're going to find a few solutions to this equation. So this is what I did to find the solutions for the equation. So I know that my coefficient or my slope for x is 2 over 3. So I fixed values for x. I chose multiples of 3 so that I could get rid of my fraction, and now I'm only working with whole numbers. And then when I evaluate it, I get these values for y, and I plugged it into here. And then I graphed it. Okay, so I want you to see, where is the y-intercept? Okay, here's our y-intercept. So again, the y-intercept is just where our line intercepts the y-axis. So pretty much, where does the line cross the y-axis? And this is where it crosses. So our y-intercept here is 0, 1. I want you to think about, how does our y-intercept relate to our equation? Okay, now let's look at another. We have y equals negative 3/4 x minus 2. Okay, so I found a few solutions to the equation, and then I fixed values for x. I chose multiples of 4 to get rid of my fraction, and then this is my graph. Okay, so where's my y-intercept? It's right here. Okay, how is my y-intercept related to our equation? Okay, and I also want to talk about slope. So remember, slope is for every x that grows, how does my y change? Okay, so for every x, so here I have 4 x's, and then y decreases by 3. So y decreases by 3 for every 4 that x grows. So this is my slope here. Okay, so if you can see, it matches the coefficient of my x. Okay, now let's look at one more equation. I have y equals 4x minus 7. Okay, so I did the same thing. I found a few found a few solutions to this equation, and then I just graphed it. But I was only able to graph 3 points because my graph only goes until -10 to 10. Okay, so what is the y-intercept here? Right here, 0, -7. Now how does this relate to my equation here? Let's take a look at the slope. So for every 1x that grows, my y grows by 4, right? So my slope is 4/1, and that's what my slope is. Okay, so let's take a look at all three graphs together. Okay, my y-intercept, my y-int here, this was 1. Okay, my y-intercept here, this was -2. And my y-intercept here was -7. Okay, so whenever we have an equation written in slope-intercept form, we can easily see what the slope is and what the y-intercept is. Okay, so let's get a formal definition. So again, all the equations we saw in this lesson were in slope-intercept form. And slope-intercept form is just when we have something that is in the form of y equals mx plus b, where y is isolated or by itself on one side of the equation. Okay, and so m stands for the slope, and b stands for the y-intercept. All right, so So here, y equals 5/2x minus 4. Our slope was 5/2, and our y-intercept was -4. Okay, so how can we graph this? What can we do? Okay, so we know that our y-intercept is -4. So we can plot one point there because that's one of the solutions to the equation. So how can we figure out what another point would be without solving? Okay, we can actually use the slope. So we know that the slope is just a ratio that tells us how much y grows for every x that it grows. So 5/2, it tells us that y is going to grow for every 2 that x grows. Okay, so I'm going to take another data point. 1, 2, 3, 4, 5. So y is going to grow 2 for every 2 that x grows. Okay, so there we have one point. We can create another one. So it's going to grow 1, 2, 3, 4, 5. 5 y's for every 2 x's. Okay, and then we can keep going if we like. 2, 3, 4, 5, 1, 2. Okay, and I'm just going to stop there. And then now we're going to take a line and we're going to get a ruler and then connect our points. So if you notice, my line has 2 arrows so that I know that my line goes on forever. Okay. So if my y grows 5 for every 2, that also means that for every 1 that x grows, my y grows by 2.5. Okay? Right, so if you remember, all the points on my line are solutions to the equation. Okay, and the slope tells us how steep our line is. Okay, so let's talk about how we would graph an equation if it wasn't written in slope-intercept form. So this form right here, where x and y are on the same side, and the coefficients in front of x and y are whole numbers, this is called standard form. Okay, so standard form is when it looks like this: ax plus by equals c. And A, B, and C are constants, or they're just numbers. Okay, so let's talk about how we would figure out what the y-intercept and what the slope are for this equation. So what we're going to have to do is we're going to have to isolate our y so that we can change this into slope-intercept form. So what we're going to do is we're going to subtract 9x from both sides, okay? And this is the subtraction property of equality. All right, so now we are going to subtract the 9y's and we get negative 3y equals 15 minus 9x. Okay, so it's not quite in slope-intercept form yet. Okay, we want the coefficient in front of y to be positive 1. So what we're going to do is we're going to multiply by the multiplicative inverse of negative 3. So we're going to multiply both sides by negative 1 over 3. We use a distributive property here. Negative 1/3 times 15 is negative 5. Negative 1/3 times negative 9x is positive 3x. We're going to use a commutative property to switch these around. So we have y equals 3x minus 5. Okay, so now this is written in slope-intercept form, and we can easily tell what the slope is and what the y-intercept is. So what's the slope here? It's 3, right? And what's the y-intercept here? It's 5. Okay,